Great.
Okay, so I think we're ready to start. Hello, everyone. I'm excited to join you all from different parts of the world to talk to you today about UCL Biochemical Engineering careers and what that entails, what that is. I want to welcome everyone that has joined us today and just say thank you for taking the time out to get to know a bit about what we do here at UCL Biochemical Engineering. And we're happy to take questions at the end as well and kind of lead you in the right direction in terms of any doubts that you might have. We're happy to address or at least tell you where to find more information. So just to introduce myself briefly, as Kim mentioned, my name is Chika. I am a senior teaching fellow here and the careers liaison officer in the Department of Biochemical Engineering at UCL. And so I think for that reason, it was thought that I was a good candidate to kind of talk you guys through what biochemical engineers do here at UCL, kind of what we study, how this translates into the real world, what our graduates go on to do. So that's essentially what today's webinar will be about. So what I'm going to do is just going to make my presentation larger so that you can see it better. Okay, so I'm going to talk to you firstly a bit about what biochemical engineering is. I'll also talk to you about the types of degree programs that we offer here in the Department of Biochemical Engineering at UCL. As I mentioned before, what our graduates go on to do. Some examples of recent graduates, past alumni that have gone on to have various successes, and how that all links back to their experience here at UCL Biochemical Engineering. So what is biochemical engineering? So I know that a lot of you know about chemical engineering and what that entails. So I want to talk to you a bit about what biochemical engineering is specifically. So it is very much an interdisciplinary subject area. There are many overlaps with chemical engineering. So we did in fact start off as part of the chemical engineering department, sorry. I think just over about 20 years ago, we broke up into our own separate department of biochemical engineering. And in terms of what we actually do, as I said, it overlaps a lot with chemical engineering, so we share a lot of common concepts and subject areas, such as the fundamentals behind maths and thermodynamics, mass transfer, fluid flow, that kind of thing. But I think what makes us unique as a department of biochemical engineering is how we apply those concepts. So we tend to apply those concepts more to the biotechnology side of things. So an example would be, for example, whilst the chemical engineering department might focus on, say, petrochemicals and oil and gas, the biochemical engineering department would look to tailor that to the more biology-based applications. So it could be, instead of petrochemicals, we look at biodiesel. We look at the application and the manufacture of biodiesel. We look at the application and manufacture of biofuels in general. There are many systems set up in order for us to get a greater understanding of that. So that's just one example, but there are many examples of what we do as biochemical engineers that I will come on to in a bit. We also look to perhaps optimize ideal conditions for cell growth, particularly if that cell is harboring a therapeutic medicine. So we not only look at, say, the biodiesel side or biofuel side of things, we have other parts of biochemical engineering where we look to perhaps, say, generate cell culture for cell and gene therapies like retinal therapies, for example, or we look at the manufacturing of pharmaceuticals and medicines. So you can imagine how important it is to have a field of study that specifically identifies and addresses these issues, especially in a world like the world that we're living in today, with the demands of new diseases, new environmental issues that we're facing today that we perhaps weren't facing 30 years ago. So it's never been more important to have a department and a specific focus area that really hones in and addresses these issues specifically. So a bit about the degree routes that we have in UCL Biochemical Engineering. So I should start off by mentioning that we are one of the first departments in the country to have a separate department of biochemical engineering. It's very much pioneered by UCL. And so as a result, we are one of the first departments to offer degree programs on biochemical engineering. And we offer 3 main undergraduate routes. So what these routes are is, so for those perhaps interested in pure engineering, we have what we call our BEng and our MEng biochemical engineering routes. And our BEng is for 3 years and our MEng typically for 4 years. So that's a master's in biochemical engineering, that's the MEng route. We offer 2 more undergraduate routes. So the main difference between the BEng, MEng biochemical engineering and the BSc bioprocessing, both of them, it tends to be to do with the types of A-levels that you choose. And our website does kind of detail the A-level requirements for each of those. And it tends to be that if you have maths and you're quite strong in maths, you would go more for the biochemical engineering BEng, MEng route. But if you don't have maths, you're not at a disadvantage because, as I said, we offer the 2 BSc programs in bioprocessing. So that's science and management and business, science and engineering and business and management streams. So the BSc bioprocessing science and engineering route would have the same kind of fundamentals of biochemical engineering and focus a bit more on the science and engineering practicalities behind bioprocessing. The BSc in bioprocessing business and management route would focus a bit more on the commercialization aspects of biochemical engineering and bioprocess engineering. So you would look a bit more into how to build business and management strategies behind companies that are kind of biochemical engineering based or biotechnology based. So they both have biochemical engineering fundamentals, but depending on where your focus is, you have options as to whether you are more science and engineering focused or whether you're more business and management focused, in which case it kind of covers all areas, and it's good for you to kind of weigh up where you are and go for. I think you have a lot of options to choose from, so that's a good thing. So yes, so our year 4 MEng option. So previously I spoke to you saying that we have a BEng MEng option. So the BEng MEng option, the BEng being 3 years and the MEng being a 4-year master's degree program. In the 4th year of your MEng, we have it broken down into various options. So you can choose to spend your 4th year in any which way, really. And here we've kind of broken down the different routes that you could take as an MEng student. So we have the kind of the pure MEng biochemical engineering route, where you would continue advanced studies on design, and you have a research project that you would be able to choose and work on a research-based project in a lab, or not necessarily in a lab if lab is not really your forte. You might have other interests that are perhaps more computational based, or more to do with life cycle analysis, for example. And if that takes your fancy, that's something that you could choose to do in the 4th year on the Biochem Eng route for the MEng. We also have the MEng with chemical engineering in your 4th year. So that's something that is hosted by the chemical engineering department. And you will get an opportunity to learn a bit more about the fundamentals behind chemical engineering applications. So you'll have the 3 years that you did initially in the biochemical engineering department, where you learn all about the fundamentals and the applications towards bioprocessing, biochemical engineering, biotechnology. And then in your 4th year, you'll be able to explore a bit more about chemical engineering applications as well, if you were to opt for that route. We have another route, which is MEng with business and management. So for those of you that were perhaps, that may perhaps toy with the MEng biochemical engineering and the BSc bioprocessing with business and management, you're not at a disadvantage if you take the MEng route, because in the 4th year, you will have the option, or the opportunity, I should say, to add business and management to your degree program. So you'll be able to develop advanced concepts about business planning and the commercialization of biological products. So that's a popular route, and it's recommended if you want the advantage of having a master's degree and you want to incorporate a bit of business and management in there into your biochemical engineering master's degree. So these last 2 options, MEng study abroad and MEng year in industry, I'm going to talk to you a bit about, because they are both exciting opportunities for you to work or do your 4th year off-site. So I'll start off with the MEng study abroad. So what that entails is, in your 4th year, you actually get the opportunity to spend a year at another university and do your 4th year in biochemical engineering there, and take module options based in that university. And a bit later, I'll give you an example of a student, a former alumni of ours in the department, that chose that option and kind of what she got out of it as well. So there are many international and excellent universities that have affiliation with UCL and with our department in particular. And it's a great opportunity for you to explore what biochemical engineering is in another academic institution, and for those credits to still come back to your degree and really help form you as a person as well. So it's an excellent opportunity, and one that is quite popular with our students. And then the MEng year in industry is also an exciting opportunity for you to spend the 4th year of your master's degree off-site in industry. So it would be a taste of day-to-day life, working in industry on actual projects, applying it to real-life applications. It would be like working in a company, but your work's contributing towards your degree program. You get various options as to where you're able to work. You get various options as to the type of areas within biochemical engineering that you would want to go into. So it's a fantastic opportunity. As I mentioned before, there are many areas that you could go into if you are kind of interested in that regenerative medicine aspect of things. You could definitely go into that. If you are more interested in the manufacture of pharmaceuticals and medicines, you can go into that. If you are more interested in the other applications that we have in biochemical engineering, the year in industry is a good way for you to kind of decipher where, what positions you are likely to obtain after completing your degree. So a number of options that we have in your fourth year of biochemical engineering degree, and we couldn't recommend it highly enough. And as I said, later I'll talk to you about one of our previous students that has chosen one of the popular options and just kind of let you know how she got along. So, iChemie accreditation. What is this and why is it relevant to you? So, what this is iChemie is an establishment that allows chemical and biochemical engineers to achieve chartered engineering status. Okay, so as a chartered engineer, you're globally recognized as an engineer who adheres to particular professional competence and commitment, and works in a safe way and has external validation from your peers. So how is that related to our degrees? So our BEng, MEng degrees are iChemie accredited. And what this means is that it's a first step. If you were to join our biochemical engineering BEng, MEng degree program, it's a first step towards you gaining chartered chemical engineering status. So if you were to, as a graduate, go off and work in a global setting or in the UK or abroad, your degree would be recognized as being iChemie accredited. And what we do also find is that in general, chartered engineers do get paid more than non-chartered engineers. So this is just one of many examples of how a degree here in biochemical engineering can put you one step ahead of your peers that may be studying something similar at a different institution in a different department. So it's definitely something that has weight and that will kind of put you in good stead going forward. So we touched a bit on this earlier, but I wanted to talk to you in a bit more detail about what biochemical engineers actually make. So we talked a bit earlier about what kind of the focus of chemical engineering. How does this overlap and how does this differ with biochemical engineers? So one thing I will start off by saying is that there are a vast array of biochemical engineering applications. And I'm going to talk to you about four main ones, but there are many, 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 many more that I might just mention ad hoc throughout this presentation. So I'll start off with one of the main focuses perhaps in our department, being to do with the manufacture of biopharmaceuticals. So a number of you would have heard of vaccines, and a number of you would have had vaccinations, I should say. You've heard of antibiotics and various immunotherapies. And as biochemical engineers, we are responsible for the manufacture and scale up of these therapies, vaccines, antibiotics, immunotherapies to treat various diseases and various illnesses. And we are also responsible for the formulation of these therapies. So when I say formulation, what I mean is how these therapies will be administered. Will it be administered in as an injection or as a tablet? So we kind of oversee the production and the manufacture of these types of therapies. Also, another area, a really popular emerging area, is the area of regenerative medicine. So in biochemical engineering, and in terms of what biochemical engineers go on to make, it can also be to do with the scale up and manufacture of cell and gene therapies for the treatment of various diseases. I mentioned earlier the type of the societal changes that are going on at the moment because of emerging diseases and kind of medicine becoming more personalized. And regenerative medicine is one of the pioneering fields that allows for kind of more personalized medicines. So we are really at the forefront of the manufacture and scale up and commercialization of these types of therapies. So that is something that biochemical engineers in our department study during your undergraduate, and something that they later go on to do as a working biochemical engineer. Another area is kind of linked also with chemical engineering. It's to do with fuels. So we know about the whole issue of the environment and the use of non-renewable fuels, and that might be something that they look at in chemical engineering. In biochemical engineering, however, we look at how to use renewable sources for the scale up of renewable sources to provide energy for the masses. So we look at more bio-based fuels. So we look at the production and the scale up of, say, biodiesel, bioethanol, biogas. We look at the use of, say, solar energy. We look at the use of wind energy. So those types of energies that are renewable and environmentally friendly are our focus, and how to enhance those energies, because we know one of the problems is that with non-renewable energies, they tend to be easier to harness and easier to grow. With renewable energies, there's a lot of kind of waiting around for the growth of those biological systems. But here in biochemical engineering, we look to see how we can accelerate that in order to provide a more environmentally friendly alternative. So again, that links to a lot of the fundamental learning that you would do as perhaps a chemical engineering, but the application would be very different. Another area which is quite hot and emerging at the moment is in the area of synthetic biology and biomaterials as well, bioremediation. So we look a lot as biochemical engineers at the use of, say, organisms, bioorganisms, in the degradation of, say, plastics and oils, things that are causing a lot of global issues environmentally and otherwise, like the buildup of plastics in the ocean or the oil spills that occur throughout the world. We look and see how biological systems, or how we can adapt biological systems in order to deal with those crises at a larger scale. So we might take an organism, for example, and look to see how that organism works to perhaps eat up oil in the ocean, and look to see how we can perhaps speed up metabolisms, or how we can amplify the organism and how it works in order to maximize the amount of, say, oil that it can eat up, or plastics that it can eat up in the most environmentally friendly way possible. So that's just 4 of many things that we do. We're also involved in the manufacture of foods, involved in the manufacture of cosmetics, involved in the manufacture of a number of areas that are applicable to biochemical engineering. So again, you're not kind of contained in one area specifically. You have the option to go and look into many areas and apply the fundamentals of what you've learned as a biochemical engineer to solve real global problems. So I mentioned about what biochemical engineers do. So in terms of how it translates when you come to learn about biochemical engineering in our department, and the types of fundamentals that we give you, I wanted to talk a bit about what we call specific unit operations that's kind of embodies the system of how things are produced in biochemical engineering. So I'm going to just ask you to imagine for a second. Let's take the example of an antibody for cancer therapy treatment. How do we identify this antibody, and then how do we make it in large enough quantities to supply to the vast number of people that are in the unfortunate position of needing this treatment? So we would first need to, what we do is we would first need to inoculate our cells with this antibody. Once we've identified what the antibody is, you can imagine that the antibody exists in very small quantities. And one of our first challenges is to amplify and grow this antibody so that we can produce it in large quantities. And how we do that is we first inoculate our cells with the antibodies, and then we look to grow these cells in a fermenter. So when we grow these cells in a fermenter, the cells, they grow, they proliferate, they multiply in the fermenter, and we scale this up gradually. And then in the fermenter, you would eventually get millions of cells that contain this specific antibody protein that we are looking to use to treat cancer patients, for example. And so that's what we call upstream processing. So you can see there on the slide, upstream. And so in upstream processing, we are growing our cells up into perhaps factors of million cells. But then what do we do with this afterwards? Afterwards, we need to somehow get that antibody out of the cells. We need to isolate the antibody. We need to purify it. So what we do is we then take a series of unit operations that are together known as downstream processing in order to separate out our antibody from our cells. And one of the earliest stages of downstream processing is centrifugation and cell lysis. So here we'd be looking to break open the cells. So we need to break open the cells in order to get our antibody product out of that. And then once we've broken open the cells, our antibody product is somewhere within all the things that come out of a cell. So how do we then isolate the antibody from all of those other things that come out of the cell? We use a series of other unit operations. We use filtration, we use chromatography, which are both involved in the separation and the purification of our antibody fragment. So I used antibodies as an example, a real life example, but this can apply to a number of therapies and a number of medicines that we would be looking to scale up manufacture as well. So as I said earlier, we could apply this to perhaps hormonal treatments. We could apply this to other types of biopharmaceuticals. We could apply this to biofuels, to biopolymers, a number of things that we would be involved in discovering and translating into products and processes. So in terms of our involvement in the discovery to manufacture of products as I mentioned earlier, we're very heavily involved in the manufacturing side of this journey. And as biochemical engineers, we will always have to answer key questions in this journey. So not only will you have to answer how you'll make the product, you have to ensure that you can make it to the amounts that are needed in order to treat the population that you're targeting. You also have to make sure, or we as biochemical engineers also have to make sure that the product that we produce is safe and meets regulatory requirements. So that is where our downstream processing becomes vitally important, because during that stage, that's when we really purify the product, and we have to make sure that it's pure enough and in the adequate form in order to be administered to patients. And it needs to meet regulatory standards as well. And as engineers, we must always be conscious of the cost of these manufacturing processes. So we need to make sure that it's safe and make sure that it's cost effective. So you need cool heads, you need to be able to deal with these kinds of questions and these kinds of challenges as well. There's a lot of money involved in this, so you need to be as mindful of that as possible and really weigh up the risks that are involved in this journey. So, in a nutshell, biochemical engineering encompasses all of these subject areas. So it encompasses a little bit of chemistry, a little bit of physics, mathematic fundamentals, the applications to biology, obviously the engineering fundamentals that come with those applications. And I mentioned earlier, it is very relevant to medical applications as well. You have a bit of biochemistry thrown in there, and as I mentioned earlier, the business side of things, the commercialization side of biochemical engineering. So we touch on a number of these subject areas, and as you go through the degree program, you have a little bit more autonomy as to where your focus may lead. So you may be someone who really loves their maths, but doesn't necessarily want to give up on the biology. So as you go through your degree program, you get options as to where your focus areas or your interest areas might lie a bit more. So you're not constrained in any way. So what areas or what industries can you work in with biochemical engineering? So you'd be surprised as to the sectors that our graduates go into afterwards. It really is vast. So obviously we have the obvious ones that are biotech companies, stem cell companies, pharmaceutical companies. Because as I mentioned earlier, if that is your interest, you can really tailor the biochemical engineering degree in that way. You are as competent as, say, a chemical engineer in the area of petroleum and chemical engineering fundamentals. So you have the option of going into that as well. You're not limited. And there are also industrial biotechnology firms and, as I mentioned earlier, biofuel companies as well. But you can also go into the finance sector and the management consultancy sector. And if you remember earlier, I mentioned about how the degree programs can really tailor you towards those areas as well. And because of the skills that you pick up in that, a lot of our graduates also tend to go into the finance areas. And even if the stream that you pick is not necessarily heavily affiliated with the business and management side of things, the skills that you pick up as a UCL biochemical engineering graduate are second to none. So you would pick up very good critical thinking skills, analytical skills. And these are all very highly sought after in financial companies. I was quite surprised to see, well, surprised and not surprised to see our students go in, not just go into these companies, but really thrive in these companies compared to students that may have taken a more direct financial route into those companies. So, as I said, you're not limited, you're not constrained. There are a number of things that you can do with this degree. Also, we have graduates that go on to do law conversion degrees. So they go into law afterwards, and they tend to apply their skills in biochemical engineering to the path that they choose when they do their law conversions. So, and also with scientific journalism as well. So with the skills that you learn on the biochemical engineering degree here at UCL, it really can prepare you for scientific communication as well. So you do learn a lot of communication skills in this degree as well. So yeah, it's definitely an option if that's something that you are interested in. If you kind of don't want to lose your communicative edge, but and you want to apply that to your love and interest for science and engineering, that's definitely something that you might want to consider. And I think what is particularly special about this department is that a lot of our students tend to go on to do PhDs and NGDs. They tend to, because of the vast array, as I mentioned to you before, of areas that you could go into, we tend to get our students stay on and go to do further research as a PhD student or an NGD student into those areas and how to enhance and develop them for their global application. So again, if that's something that you are interested in, you would only be at an advantage if you had a strong biochemical engineering degree background. So a number of areas that are related and not necessarily related to biochemical engineering. So yeah, this is just kind of a mind map of a number of areas that our graduates go into. I mentioned finance, I mentioned law, I mentioned pharmaceuticals, PhDs, biotech, medicine-related professions, journalism, research, stem cells. I mean, it's just an endless list. But again, non-restrictive. I should also mention consultancy is a big one that our students tend to go into as well, particularly with that kind of business and management drive that we have in some of our degree programs. It really is something that appeals to our students a lot. So again, it's open, it's limitless, to be honest. So I wanted to show you guys a bit about, just to kind of back up what I was saying a bit earlier about where our graduates tend to go into. I have here some top 10 employers taken off of our uni stats. And you guys can see here that it really does vary. So we have at the top, we have Accenture, we have Autolos, which is a cell and gene therapy company. We have consultancy companies, as you can see in there, in that top 3. We also have GSK, which is one of the hugest pharmaceutical companies in the world globally that recruit our students because of the uniqueness of the degree. So that's a big selling point, a big driving point in our degree. You guys can see on there, JP Morgan, one of the biggest financial, and they have a consultancy area as well in that company. And our students get recruited into that company as well. So you can see Lloyd's Banking Group as well. So you can see not only that there's a variation, but that they are some of the global leading companies in the world. And you shouldn't expect anything different, to be honest, if you are looking to get a biochemical engineering degree from UCL. So it's definitely something that we tend to kind of, you know, bring up to not just prospective students, but once our students arrive at UCL as well, they have opportunities to get close to industry. Right from their first year, there are many opportunities. So again, definitely something for you guys to consider. So I have just below that top 10 occupations that our students tend to go into. So right at the top, there's management consultant and business analyst. So for some of you, it might be a surprise, but because of the skills that you pick up as in this degree programs that we have, that we offer, excuse me, a lot of our students tend to go into management consultancy firms, as well as the traditional production and process engineering firms as well. So you can see there that there are, not only that there are an array of occupations that you could go into, but you're not limited by the kind of the degree program itself. And then in terms of starting salaries, so what we tend to see is that there is an average starting salary of about over £27,000, but this does then increase 6 months to a year after starting your graduate program. Again, your graduate recruitment. So again, it does depend on the type of company that you go to. There are companies that offer more. So again, once you are a student here in the department, myself as the careers liaison officer, I do tend to help students get onto the best paths for them, not just financially, but also to do with the direction that their careers that they want to go into with their careers. So again, that number is really dependent on the type of company that you go to, but it's a good indicator as to what you can expect to maybe get later on down the line, and the increase of salaries that tend to come later down the line. So one thing we are quite proud of is that our graduates do tend to go on to be happy with their employment and actually get employment afterwards. So we can see here 90% of our graduates go on to either further work or study. So that's, again, something that you as prospective students or students that are thinking about joining UCL Biochemical Engineering, is something that you would benefit from in our department. So I wanted to talk to you a little bit quite quickly about our recent graduates and our alumni and what they've gone on to do. So just generally speaking, from the BSc degree program, we've had students go on to do management consultancy, as you guys saw before, to do further studies in international health management, or to go on to work in various banks, such as Bank of America, Merrill Lynch. And then from our BEng, MEng degree programs, we still had students go into management consultancy and also go into more traditional bioprocess engineering-based opportunities. And then also go on to do further studies, MSc in advanced chemical engineering, or management and manufacturing types of degrees. We get a number of students that stay on to do NGDs and PhDs, and we have close contacts with various people in industry, such as at GSK, Eli Lilly, and other companies as well. So that's just generally what our most recent graduates have gone on to do. So some examples specifically from alumni. So the first example I have here is a guy called Tom Sutton. he has quite a varied path connected to our department. So you guys can see on the screen that he started off really quite early, and his degree in biochemical engineering allowed him to network with a number of industrial contacts that we have here in the department. And because of that, he was able to get jobs in Australia. He was able to get various positions within various engineering companies. And then he then made the decision to move back down to London, where he is now in great positions within companies such as Thermo Fisher. He's recently come in to give careers talks in the department. So one thing that I will say about this department as well is that we always kind of appreciate the students that we have and are willing to kind of bring our students back and share those experiences to inspire our current students and our prospective students as well. So Tom is an excellent example of that. The next alumni example that I have is a young lady called Charnette, who's actually just finishing her PhD in our department. But she started off also as an undergraduate in our department as well. So there's some information there about the types of A-levels that she chose. And she chose on her degree program to go with the MEng Study Abroad program, where she did her 4th year at the University of Toronto, which is one of the most established universities in Canada. And then with that degree, she came back to Europe, and she worked in Eli Lilly for a year because of the contacts that she had with the department. And then after working, she went off to do further studies. So she, as I said, she's just finishing off her PhD, and that's mainly to do with life cycle analysis. So her PhD explores the way that we use biological products and how that goes through the system and how that affects the environment and how we can improve the environment as well. And she's consequently gone on to do more postdoctoral work in chemical engineering, where her expertise is also applicable. So it's really just, as you can see, a vast array of things that you're able to do by just being linked with the degree in biochemical engineering at UCL. So we have a vast alumni network. You can imagine that if we separated from chemical engineering over 20 years ago, so our alumni network is quite huge, and it's linked with various companies: AstraZeneca, BP, Eli Lilly, as I mentioned, GSK, Jacobs Engineering, Lonza, Paul. It's endless. Unilever being one of the bigger companies there. So we really have a really wide reach. And because of the uniqueness of the degree programs that we offer, you're always gonna be able to be kind of in contact or within reach of these companies. One of our other alumni that is now leading large biopharma is Professor Barry Buckland. So he got his PhD in our Department of Biochemical Engineering in 1974. And he has led the development of process engineering and process development of biologically made products. He's worked in various companies as a result of having a degree from our department. So you can see that our alumni go on to be quite big stakeholders and kind of global decision makers when it comes to this particular area. So a final example that I have here is Dr. Ewen Roberts. So one thing that I would say that really does set us apart from other departments in universities, that we are huge advocates of students that would like to start up companies. And one of the spin-out companies that we've had from our department is one called Purify, which was which was co-founded by two of our alumni in the department, one of them being Dr. Roberts. So if you do come into department and you are inspired by a particular idea and you would like to see how you could bring this idea to life, we really advocate that. And Dr. Ewen Roberts is an example of that with his startup company called Puridify. So there are many ways that you can keep up to date with what's going on in the industry. There are a number of journals and articles that are published by, say, Nature Biotechnology, by Genetic Engineering and Biotechnology News. And that really gives a good update as to what is going on in the industry, the new emerging technologies that are out there, and the new applications of biochemical engineering fundamentals that you guys might have some interest in. So that brings me to the end of the presentation, and we're very open to questions. So as I said to you guys earlier, I'm Chika, I'm the Senior Teaching Fellow and Careers Liaison Officer. If you have any questions at all, my email address is there, and do check out our UCL Biochemical Engineering website for more information about all the things that I've talked about. So yeah, I think we have some time for any immediate questions.
Let me just, so this is Kim, let me just put my camera on so you can see me as well. I think, Chika, just want to let you know that somebody did actually contact us with a question which we can't really answer in detail, but I thought it'd be quite a good idea to mention it. So he was asking about access for disability. I've sent them, I've shared a link to a UCL page on accessibility for students, but they did also ask about things like distance learning and electronic learning. I just thought, again, it's something we can answer in detail, but Chika, you might like to talk about how much time there is in labs. So in terms of accessibility, distance learning, a lot of what we do here is actually working with teams and working in the lab. So perhaps you just quickly like to mention that.
Yeah, so I would say from your first year of studying here, you are kind of thrown into lab settings where you could work individually or you could work in groups. We promote collaborative working in the department. So you have access to various types of labs with various types of equipment depending on what it is of the task at hand. So we have perhaps biochemistry labs, we might have bioprocessing labs, we might have labs that are more for cell and gene therapy. So depending on what it is, what subject area it is that you're taking, you would get lab experience in those different subject areas. So yeah, it's definitely a plus in our department.
Thanks. And another question that's come in is, Swati's asked if international students can start working the first year. I just want to say that there's quite a lot of information about visas, what tier you are, and it's quite a complex question to answer, and also one which you can't answer properly in this situation. So what I'll do, if that's okay, Swati, is I'll send you a link to the UCL page on international students, and if you don't get the answer there, then I can certainly look at more details for you. Does that make sense?
Yeah, that works. Yeah, it's quite a complicated question to answer just straight off. So you're probably better off looking at the information that Kim's going to send to you.
Cool. Are there any more questions? We've got a webinar chat. There's also a Q&A section. So if there are any questions for Chika or myself about careers in biochemical engineering, whilst I'm waiting for any more to come in, just to let you know, as well as the link that I'll send you afterwards so you can watch the recording, there'll also be links to useful things like our program pages. There'll be international students information if someone's asked about that. There'll be a link to the disability page. And I can also send you some more details so you can dig down into the data about where people go on to study, starting careers. It's all publicly available information. Again, you'll have my contact details. I'm more than happy to put you in touch with anyone here in the team if you've got a question that's relevant to that. But in the meantime, are there more questions from anyone who? Was there anything else?
I think on the chat, Maria has asked about finding where she can find optional modules for the bioprocessing medicines. Is that something?
Well, Maria, that's a great question. One of the issues about optional modules is, so I'm just answering from an administrative point of view, is that optional modules rely on timetabling. So we don't know, we can't do the timetabling until we know how many students are going to come, because we need to know how many are going to be in a specific room. It's quite complicated, something we do here every year, but it means that we won't know exactly what modules we can offer until we know what someone's timetabling is, because we can't obviously give you an option you couldn't do it clashed with your core timetable. So that's one thing. We also don't know how many people will be taking an option, especially if it's in another department. So say we're offering chemical engineering or chemistry or management. If they didn't have enough people to offer it, or if they have a particularly big cohort and they couldn't allow people in, we won't know until you actually sign up. I know it's not a perfect answer, but unfortunately we can't give you a list of optional modules until we know which ones we're going to be able to offer you for timetabling and availability. We do publish a list of core subjects, but up until that point we won't be able to share that with you. If you want more detail, a bigger breakdown, or perhaps if you wanted examples of things that people have studied, I can look into that. But if you email me directly and I'll send my contact details around, I'll look into that for you. Okay. Has another question come in?
Yeah. So Hai Ming, hello, says about entry requirements and what the typical offer range is. So personally, I'm not familiar with the IBDP.
Yeah, I'm guessing that's an international baccalaureate.
Yeah.
So I've got to be honest, it's not something which we have access to. That's something which will be answered by the admissions tutor, Brenda Parker. If you email me directly, I'm going to have to put you in touch with Dr. Brenda Parker. We'll see what we can find out for you. However, it's worth bearing in mind that some of the things we ask for around entry requirements isn't just because we're UCL, we have high entry requirements. It's because the modules that you'll be studying will require you to be at a certain standard so that you can hit the ground running. Chika, perhaps you'd like to explain a bit more about that.
Yeah, so with entry requirements, what it is that we want to make sure that you have the background, the right academic background, in order for you to understand what is going on in class. We don't want you to arrive and kind of be startled by the starting level. So I think with entry requirements, that's kind of what it's based around. But as Kim said, he can kind of put you in the direction of someone who can answer that in more detail for you. And he mentioned that that's Dr. Brenda Parker in our department. So if you get in contact with Kim, he will lead you in the right direction.
So we're coming to 2 o'clock. So we've got one more question that's come in. So I just thought it'd be useful to, I don't know if this is Chika, but the question is, do career opportunities tend to differ between the BSc and the BA programs?
Oh, good question, Enrico. One thing I would say is that you are not restricted by the degree program that you choose. If you chose a BSc program, you would still be open to the same opportunities as someone else who took a different degree program within the department, because the fundamentals of what you study are very similar, if not the same. But it depends also very much on what your focus is. So if you are someone that already knows before coming in that you, even though you love science and you love engineering, you want to perhaps have a more business and management focus. And therefore you kind of want to choose a BSc that is more focused to that. Or you might want to do the MEng program with business and management. And then that opens up to you opportunities that may not have otherwise been open had you chosen a degree program that took you to a different focus. I hope that answers your question a little bit. So in general, you're not restricted by the opportunities, whether you choose BSc or BEng program. It would very much depend on what your focus is and what you're looking to get out of the degree program. So let me know if I've answered your question. I hope I have, Enrico, but that was a very good question. Thank you for that.
Just to say, I'm just going to put my other hat on here, but I also work with the team in the MSc, so postgraduate talk. So if you do a BSc, you are, of course, able to go on to do a bit, and if you do the BSc, you can go on to do an MSc. So you do a postgraduate talk program, which will, again, develop your skills, and you have certain options in that. I think that's something which is a lot of students go to. Now, the lights are actually dimming in this room because we haven't moved enough in the last few minutes, but I think that's the perfect point at which we should say thank you very much.
Yes, thank you very much, guys, and thank you for your questions. They're all very interesting. Well, the lights are telling us to go. But thank you, guys. I wish you all the best, and we do hope to see some of you soon here in the Department of Biochemical Engineering.